Hello, I'm going to be quick this time. So the let's say you have the Google Analytics, you have the data that you can pull it from the database. So for example, you have this database. This is Google Analytics, and you want to get some data. And this I'm getting here the segment from for like a month maybe. Let's say for 1 month. So if you see to get the data for a month, it takes 1 second to get the data, any data from Google Analytics. It is very fast. If you worked with the big data, like maybe 10 million data, so you know that it's so hard to get this data in a second because it will it needs to go through all the tables in the columns in the table and all these rows and it's to get this data. So usually this involves a lot of calculation. It needs to calculate everything. And if you see the longest it takes is like 1 second, 2 seconds. So let's say, so the first when I was starting doing this SQL schemas, I thought why not to cache everything? And I thought that everybody caches. So like daily, hourly, weekly. But when I started doing the segments, it was hard. It is hard to cache for each segment or some kind of segment because if you say let me get like weekly data and segment it as cache weekly, I might be doing like the half of it. So it is so hard to predict what what the date ends. Like you cannot do it like weekly, monthly. You cannot cache this data. So let's say if I want to have like a year of data, and it still takes less than like 1 second, 2 seconds to get that. The reason why it does that is, so the concept that we learn at the beginning of the database, we learn normalized database. And the normalized database is, for example, if we have this table and users table has address, contacts, we put here all this data, but we don't put data here because if person has like two addresses, we cannot put here two addresses and say okay, this will increase the row count because you are adding one user with one address, then you add the same user with the second address, and it's repetition. So what do you do is you create another address table, and you just get the IDs from the address. You get IDs from here and put here as an array, and you say this address is here. So whenever you're getting this data, what you do, you say okay, your SQL data is uh, will do, and it will say okay, select from users and where and then address is, and from address it will just select through this address, and then if there is another address it will get the same thing. It will just get where and the select address in address. So this is one thing. And then if you have context, you do the same thing. The context might have phone, email, and the so all contacts. I don't remember. So usually it's phone, email, and the other thing. So you get that from the context. And to do that, there is algorithmic calculation called ON. It's a very simple concept. If you're doing one calculation, you calculate how many times you you look through the thing. Like for example, when you're creating these tables in your mind, according to this algorithmic calculation, you do by millions. Not like I will have 100 people, so I don't care, but you do like okay, if I have 1 million users, so to get this user, if it takes 1 second to get this user, but there would be another second to get address and another second to get context. But if you have multiple contacts, it will increase. So you say okay, ON, and then you say O2N or 3N. It depends on what. how many times you do. So what it will do is, for in your SQL, you say select from users where, and there is another select inside of this, and you get this. So if you have 1 million users, it takes 1 second. You go through the address, another second to get that address, and then another second to get the contact. So it takes 3 seconds to do that. So what the con what this another thing I want to show you is the denormalized tables. So what you do here, after having all this normalized table, you have all relations connected to each other. You look um, at your um, relation, like you'll say, okay, new users. So for new users, you are going to create another table. Another table, it will be only calculating new users. You don't care about the old users, you don't care anything about anything, you just do that. Or usually people go and say, um, let me get the a cost of anything. Like it will say, um, like new users and or page views. You do only the table just about the new users. So your one table, it's called fact model. You will look at your code, how you calculate this. You say, okay, to get the new user, I need the users, and then I need to get their enrollment date. So not to spend a lot of time to do that, you denormalize that table. You say, um, for example, you create new users uh, table, and here you duplicate the data. You will look at your SQL database. If you have like subqueries and this table has another subqueries, you put all those into one table. So yeah, there would be some redundancies, some data will be repeated, like there would be user type, for example, it would be repeated on each row, but you're not making extra call because it's here. So it will say, okay, user ID, then it will have address, contact. You might not need this for new user, you might need only user ID, and you will see, mm, you will have like registration date. That's it. I i don't know about the thing, but um, this would be the simple thing to do, like registration date. You're not going through all this subqueries. It is one. You say, okay, get me anybody from this registration date, and you say I will need username, for example. That's it. Or I'll need a full name. That's it. You're not getting username, full name from anywhere else rather than just one table. So this is just simple. You might need to have some queries, some subqueries, but it would be one hand. Like it will have one context. That's it. You're not going through the other contexts. It's just one context here. So if you search for denormalized tables, you will get a lot of suggestions when to use denormalization, how to use it. Sometimes you don't need to denormalize. Sometimes you need to create a fact models that will be repeated everywhere, like user. You might have one user table that your denormalized tables will get it from. It would have all these things. For example, you can say how much money is one user spending. So to do that calculation, you might need to have one denormalized table like this user. Here it will have everything inside, and then from there you're creating another table that will say, um, for example, add cost. So how much money you're spending to get one user, for example. And you can do that by just getting the like overall overall money, overall cost, and then the only thing you will do is user ID, and this user ID is not from the user, the normalized table, but from the normalized table, the one that is calculated here. So there would be some things that you need to take into consideration if you want to use the normalized table. The main thing is, how do you update this denormalized table, because you're not directly putting data into here. Whenever user is registered, you put into this one. So one thing might be reading the logs from the MySQL database. So MySQL database will create logs of the data, where you can put one worker that is just a cron job that gets the log data and reads that data, and then we'll say, okay, here is the users table updated. Let me message to all tables, all the normalized tables that use user. Let me say, okay, this user is updated, do whatever you need. So if I need to if this denormalized table needs this user, it will update. But if it's referring, it does not need to update it. There is dedicated table that is updating this new user. So that table will update. Not all of the denormalized tables need to go and update the same table. There is one dedicated table that said, okay, I will take care of it, and it will go and say, okay, address has changed, let me change address here, and it will just update it. So you can do that. If you're using the cloud or something, you can use the messaging, or I don't remember the AWS name, but it's the same messaging idea, where it says when I update that, I will just send a queue. I guess it's called queue. You put into the queue, it will say, okay, this is updated, and this queue will always be messaging to this uh, tables that use it. There is a script that's waiting for update from that queue, and whenever it's updated, for example, lambda function, it will say, okay, it will be pinged by the SQL server, the queue or the messaging system, and when it's pinged, it will say, the lambda, for example, will say, okay, let me go and search for the things that whether the things that I need have been updated. So it will go look through this queue, and it'll say, okay, this is updated, so let me go and update it from the normalized table here. So this is the denormalization. It is just very simple explanation, but if you need this data to get all the segments, you cannot do other ways. whatever you Whatever way you do, it will be longer, because some people I know, user, they try to simplify the data to normalize and make it faster. They convert each column by the indexing. So they create their own indexing. For example, they instead of um, setting SQL server or some kind of server, instead of letting it do, they do it manually. They go and create only one user table, and there would be two columns: user ID and user hashing of the user. So they will convert this user into number, um, and then they search by number. So when you sort by number entire database, you can then find it by using the algorithmic calculation. So each of this would be separate column, and then they search through each column, and they think that it would be faster, but denormalize it would be much faster, because you are not getting any subqueries. The only subquery you will have is when you're using um, one one fact model that is everybody using, like the user. So this would be used for by everybody. You don't need to create users every time. So you can say, okay, we have user, and let me just use it, and you just get the user ID here. And if you have like overall cost calculation, so you do like, how much is the ad cost, how much, for example, YouTube cost, how much Google ads, and all these ads, instead of creating the separate tables, you create one table with all these ad costs. but your normalized table will have them separate tables. But here for this one, you denormalize into one. You put into one column and you'll sell it at cost or something like, and then you will say YouTube, the price, and all these prices for one user. Like you'll say user, and then here all the details like YouTube cost, and then you will say AdSense and everything, and you put here. And then when you're pulling, you just pull one user. So instead of doing 1 second, 1 second, 1 second, you are having one denormalized and all of them normalized. Because if you didn't normalize, for example, YouTube cost and then the AdSense, advertisements, everything, you need to create each second for each of them. But by doing, by creating your um, one by creating only one table, like cost table, and here you create like YouTube column, then Google Ads column. So you are saving, basically you're saving 1 second, 1 second from each tables, because um, you will have here one column for YouTube and one column for Google Ads. So each of them is 1 second. So you're saving a lot of time by doing that. Um, I think it's a good concept. Just look at some courses on normalized and denormalized, for example. Um, Denormalized schema. So it can show you, for example, here you have all this product code and items, everything inside, but instead of that, you denormalize and put into item and product code and into one. So there are a lot of ideas of denormalizing, but you need to understand the concept, because you need to understand how many tables you need to do, and what kind of schema I need to have. Like this one, like the snowflake one, or the different one. So you need to look what kind of um, denormalized table you will need. I showed you the snowflake star model. I showed you the star model. So the star model is only one handshake. So there is no any other handshakes like here. So it's only one handshake you can get only from one data. But if this kind of table, it has more than one dependency, it's better to pull the main dependency, the fact column, and you just put it here. You just move it from this all this data, move into here, and you'll say, okay, this fact model is um, so, because this one is nothing but the calculation of all these fact models. So you need to get the base, whichever which whichever column is referred here. You just pull that here, and here you look how many columns are taken from other tables. You get all columns and put into one, and then you from here you say, okay, I'm calculating these tables from columns from here and then put it here. So why not to get this column and put it here and then calculate it here? So this is the star model. You get all the dependencies and get from the main dependency into the first handshake. You don't go to the second handshake. This is the star model of the normalized table. This is the good concept. I suggest just going through that. It is very simple and it will save you a lot of time, a lot of calculation time, because of just simplifying your table. It would be hard at the beginning to understand, because you all your life you learn how to normalize the table, and suddenly you need to go and denormalize existing table. So you need to create fact models for each fact you're using, like for example page views, bounce rate, each of them will have their its own um, table. There's no way you can mix them together. Maybe Google did it, but Google uses a little bit different technology. It might be using its own caching SQL server. I know that they they look at the way you talk to the database, and it will optimize the tables according to your needs, and it will give you the data faster, but it's expensive. It's better to create your own tables and denormalize these tables rather than spending a lot of time, which can be solved just by creating these denormalized tables. Thank you very much. I went a little bit more than I thought it would be, but I think it will help you in the future to save a lot of time and frustration of the users, and users usually try to avoid waiting time, and if it's more than like 3 seconds, regularly for business it's 1 second, but if it's like you have like customers that are always in your like your paying customers or subscribers, it might be 3 seconds, then it would be frustrating them, and it will bring to the bad reviews and everything. By doing this on denormalization, you will save a lot of time, a lot of frustration, and you will get more better reviews because they will be comparing with others and everything. Thank you.